Okay, we're going to work with complex fractions. Here's some homework questions that you have for worksheets. Now, I'm going to remind you that what you have here is some arithmetic to do in the numerator, and we have some arithmetic to do in the denominator. So we're going to do these separate. So you have a numerator, you have a denominator, and then finally, we're going to divide the two. So let's do the work separate here. So for the numerator portion, for what's on top, here's my numerator. X over 4 plus x. You may notice here that the denominator is 1 and we have unlike fractions. So we need to add fractions that are like here. We have to convert our fractions to an LCM or with a denominator that's the same. Typically we find the LCM of the denominators here, 1 and 4. So we're going to try to find the LCM of 1 and 4 here. And go through that process. So we need the LCM of my denominators. The LCM of 1 and 4 is actually 4. So we're going to go through the shortcut here and multiply the bottom by 4, the top by 4. You can review another video on how to add fractions, how to subtract fractions that are like and unlike, but I'm going to go straight to what is easiest for us to do. And so let's remember that we're going to multiply top and bottom here across, and we mean horizontally across, for the second fraction by 4. So my first fraction stays as x over 4 my second fraction becomes 4x, or x4 over 4, and you're going to notice that they are now like fractions here. They have the same denominator, 4 and 4. So all we do here is add the corresponding numerators, x plus 4x, and we keep our denominator of 4. So we're going to end up with 5x over 4 here. So here's our fraction that's on top. It is 5x over 4. That's in our numerator position. We have to find the fraction on the bottom in the denominator position. So 4 over x plus x is in our denominator. And so we're going to do the same thing we did before. We're going to remember that this is over 1. And we'll multiply both top and bottom by x so that we obtain 4 over x plus x squared over x, because we're going to multiply horizontally across our x and x to get x squared, our 1 and x to get x over here. So we got the x squared over x. This is how we got these values here. Now they're like, so notice that they're like fractions, meaning the denominator is the same. We just have to add the corresponding numerators. So we get 4 plus x squared here divided by x. We can also write this as x squared plus 4 over x, because the order in which we add doesn't matter. So this is going to be what we see in our denominator position. This is x squared plus 4 over x. So we have this numerator fraction, we have the denominator fraction here, and they're asking us now to simply divide here. So here we go. 5x over 4 divided by x squared plus 4 over x. So what I want to point out here is I wrote this division, which is the same as the division we have over here. The first fraction we have is vertical, up and down. The second fraction, we wrote this horizontally, left and right. So you're going to see that my 5x over 4 is still here. And you have the x squared plus 4 divided by x over here. So how we divide fractions is we keep the first fraction the same, 5x over 4, and we multiply by the reciprocal of the second fraction, which is x over x squared plus 4. And now again we have to multiply, and you'll end up with 5x squared over 4 times x squared plus 4. Because we're going to multiply across here. This is what we mean by across. Horizontally across. So 5x times x gave us the 5x squared. 4 times x squared plus 4 is 4 times x squared plus 4, as you see. Now at this point, ideally, we would like to try to simplify our fraction. And since we notice that both terms there are factored, and nothing cancels, you don't see the same term on top and bottom, then that means we're done. This fraction, or rational, is simplified. And this is how we answer what's known as a complex fraction. It's really not complex. It's just composed of possibly arithmetic or difference in the numerator position, arithmetic or difference in the denominator, and ultimately a division. So this is how we handle complex fractions. Number 3. 10 over x over 2 over x squared minus 5 over x. So I have here, again, a fraction in the numerator position. I have a difference of fractions that are unlike in the denominator position, and they're asking us to divide. So it's a complex fraction. There's no work to do in the numerator because it's 10 over x. It's a single fraction. The only work is in the denominator. So that's what we're going to do. We're going to work on the denominator, meaning 2 over x squared now minus 5 over x. Again, we notice we need the same denominator. In one case you have x squared here, the other case you have x. So we're going to do what we did prior. In order to get the LCM of x squared, we multiply the second fraction by x, and what this gives us now is 2 over x squared minus 5x over x squared. So that my denominators here are now both the same. Two minus 5x over x squared, I just simply subtract. So this is the fraction that's in my denominator. So 10 over x is going to be divided by 2 minus 5x over x squared. First fraction divided by the second fraction. So here's what you end up with. You're writing your division horizontally now. Notice again you have first fraction, the division sign, and the second fraction. So you just simply rewrote your vertical division horizontally, and now we keep the first fraction the same. We flip the second fraction over, and again now we multiply horizontally across. So you end up now with 10x squared over x times 2 minus 5x. So this is going to be your fraction that's in the denominator position. So altogether you have 10 over x over 10x squared divided by x times 2 minus 5x. And again, this is a division question. Sorry. Take that back. This is our final answer. Apologize. Okay, however, we notice here that we can simplify. Meaning there's going to be cancellation here. Where we can simplify here, we're going to use the simplification property. So let's write that down. Simplification here. Triangle times square over triangle times that happy face. So remember what we can do with the simplification process. We can cancel our triangles out, and what we're left with is simply the square over the happy face. But what we really need here is the operation of multiplication. So in this case here, the only thing we can cancel, if we take a closer look, is that we notice that our 10x squared here can be written as 10x times x. So I'm going to get rid of one of those x's. And what we have left now is 10x in the numerator and 2 minus 5x in the denominator. So this is going to be my final answer here. Now sometimes students like to cancel, and which you can't cancel, but they're going to try to cancel this x with this x. You can't do that because you have, let's see if we could get rid of that. Okay. We can't do that because we have an operation here that's subtraction. You would need multiplication there to use the cancellation property. We can't cancel the 2 and the 5 either because of this subtraction operation you see here. So you can only use cancellation when you have multiplication between terms like this. So this is done. This is a simplified answer here. This is number 3. Now we're fine. All right, now this is simplified. So I can say this is 10x over 2 minus 5x. This here is the final answer for the complex fraction. This is all the work, however. So this is number 3. Number 5, 2x minus 5 divided by 3x over x minus 7 divided by 10x. First fraction in the numerator, second fraction in the denominator. You have division. Notice there's no work to do in terms of adding or subtracting in the numerator or the denominator. All you have to do in this case is rewrite your fraction, or the division here. Rewrite it as a division question horizontally, meaning use your horizontal definition of division. Here, the first fraction is the top fraction. Your division sign is now the division sign you're familiar with. We're going to divide by x minus 7 over 10x, and that's your second fraction. That's the fraction that's on the bottom here. So we just simply rewrote our question horizontally, left to right, and since it's division, we have to know how to divide fractions. You keep the first fraction the same, you flip the second fraction over, which is known as writing the reciprocal, and now your operation is multiplication. You still multiply horizontally across, and here's what we get. We'll get 2x minus 5 times 10x over 3x times x minus 7. Now at this point we want to determine whether we can use the cancellation property again. And we're going to find that we can, because an x will cross out or cancel out. Okay, so x's go away because of the operation here is multiplication, and here is a multiplication with the 3 here. So you got the right operations here. You end up with 2x minus 5 times 10 over 3 times x minus 7. Now notice nothing's going to cancel here. And so you could leave your answer this way, or you can kind of write it as 10, 2x minus 5, switch the order there, 3, x minus 7. This is acceptable as a simplified answer. Or you can distribute, and some people do, and write this as 20x minus 50 over 3x minus 21. So either answer will be fine as long as you know that nothing else will cancel. And this is question 5. Question 7. X over 6 minus 3 over x over 1/3 plus 1 over x. Now again, you have a numerator on top, and there's a subtraction question for that numerator. You have a denominator on the bottom there, and you now have an addition question. And don't forget that ultimately we're going to divide here. So it's called a complex fraction. Now this is somewhat review for us, or at least it should be for this course. So let's work on the numerator question, x over 6 minus 3 over x. Now there's a couple of ways to go about this kind of question. If this was a beginning algebra course, right, versus a review, you need the LCM of the denominators. 6, let's undo that, 6 and x, and the LCM here will be 6x. So if we do our setup, we put the LCM down here and put that 6x. And like we've done in the past, we just rewrite that first fraction, x over 6, 3 over x. And we need a term here. Looks like we're picking the wrong things. A term here, a term here. We need a term here. Oops, still making that mistake. Here and here, we need to multiply both top and bottom of these fractions here so that you get the LCM. So here's what we're saying. This is what we've done in the past. Let's take a look here. We have 6 and x, and then 6 times some term better be 6x. That term has to be x here. So we put an x on the top and the bottom. We got x times a term, which is 6x, so that term has to be 6 in this case. So we'll get x squared, and we'll get 18, and now our fractions are like. Same denominator, right? So since they're like, all we have to do now is do the arithmetic in the numerators, x squared minus 18, and divide by the denominator of 6x. So here's that first fraction here. That x squared minus 18 over 6x, that goes on top. The bottom work, if we take a look at the bottom now, 1/3 plus 1 over x, we could do the same way. However, we talked about this shortcut here. If we notice in the past, we've talked about this in class, since 3 and x are prime in a sense, we get to use that formula here to do a quick and easy arithmetic. Remember what we did here. This is what we talked about in class. If we had a over b plus c over d, here's a shortcut for adding or subtracting two unlike fractions. If you recall, the formula was AD plus BC over BD. Meaning we can cross multiply with these two terms, but make sure this diagonal across you keep the A on top and the D comes up. So I want to point out to people this. My A is still a numerator. It was the D term that's now on top. For the second portion of this here, okay, you're going to notice again, the C is your numerator. We keep that on top, and the diagonal term for B is now a numerator. So this is how we actually get these values here as a numerator. We do this diagonal cross multiplication. But then you might say, how do we get the denominator? Well, the denominator on the bottom here is B times D. So this is how you see this product here. Now, this is a shortcut formula that really can be used for adding fractions here that are unlike every single time, although it's not recommended to do that. What's recommended is that if these terms are prime, then go ahead and do your shortcut since they're prime. And you're going to end up with the following now. This is going to be x plus 3 over 3x, because you did your cross multiplication here. And then you did the horizontal cross multiplication. So this is diagonal cross in gray, and in blue, this is horizontal across. This is how we got x plus 3 over 3x. So here's the shortcut that we talked in class about. So you could do either method. Either is fine. X plus 3 over 3x, I'm going to put now here. And now we have two fractions here. One on top, one on bottom that we have to divide. Okay, this is a complex fraction question. So all we do is we divide, however, we write this as a horizontal division question. What you're seeing here is up and down, it's vertical. So write this horizontal now. So remember, you have x squared minus 18 over 6x. Divided by the second fraction of x plus 3 over 3x. That gives us x squared minus 18 over 6x times 3x over x plus 3. Okay, and how we multiply again here is horizontally across. You end up with x squared minus 18 times 3x over 6x times x plus 3. And at this point, what you want to see here is where you can simplify. What cancels? The 3 here and the 6 cancels, that leaves a 2. The x and the x cancels because it's the same exact term. Now you're left with here x squared minus 18 over 2 times x plus 3. These are the terms that are left. Now your 2 does not cancel with the 18. because you have the operation here of subtraction. If it was multiplication, the 2 and the 18 would cancel. The x and the x squared don't cancel for the same reason. So you're done. This fraction, or this answer, is simplified. Number 9. We have 1 over x squared plus 1 over 1 over x minus 1. So again, we have a sum on top, sum of two fractions. We have a difference on the bottom, the denominator position. We have a difference of two fractions, and they want us to divide here. So we have work to do. So let's take a look at the numerator here. This is 1 over x squared plus 1, and we can put this over 1 here. So if there isn't a 1, because 1's a whole number here, we could divide by 1. We now have two fractions. And what I'm going to recommend here, as I'm going to point out, is we can do this cross multiplication, right? And we could do this cross multiplication, meaning we could take the shortcut. When we do that, we get 1 plus x squared for a numerator over x squared times 1, which is just x squared. So this is my numerator for this fraction, 1 plus x squared over x squared. We need the second fraction. We need the denominator fraction. So we can use a shortcut here again. We can say 1 over x minus 1. We can put this over 1. Again, we diagonal across, horizontal across multiplication. Got to be careful what we mean by across. So 1 times 1 is 1. 1 times x is x. X times 1 is x. So this will be 1 minus x over x. We have the numerator fraction and we have the denominator fraction. And don't forget that we are what? Dividing here. So you have 1 plus x squared over x squared. Write this horizontally. 1 minus x over x. And whenever you divide fractions, you flip over the second fraction, x over 1 minus x, and you multiply. So here's the multiplication here. So as you multiply here, you get 1 plus x squared times x over x squared times 1 minus x. So at this point, you're going to do some simplification. X goes away for on top and bottom. So you end up now with 1 plus x squared over x times 1 minus x. And you have no further cancellation. So you are done here. This is a simplified answer here. Nothing cancels. People think that this x here and this x will cancel, and it doesn't because you have arithmetic. So that can't be done. This is number 9. Number 11 here. Seven over x squared plus 4 over x divided by 6 over x minus 3 over x cubed. So again here, we have a sum of fractions in the numerator, we have a difference of fractions in the denominator, and we divide here. So here's the deal. Seven over x squared plus 4 over x squared. We're going to take our shortcut, or at least at this point, maybe we should review a little bit of the procedure. I think this is good. Notice here the shortcut's not good because we'll have to do a lot of simplification. These two terms here are not prime here. So I'm looking at the denominator here of x squared and x, they're not prime. So we're going to have to, let's find the LCM. So my LCM of x and x squared here is x squared. So as we rewrite this first sum on top here, the LCM, x squared goes down here. We copy our fraction, 7 over x squared, 4 over x. We need a term to multiply to the top and the bottom here. We need a term to multiply top and bottom over here. So here we go. X squared times 1, remember, x squared times a term better be x squared. So the term is 1. X times a term better be x squared, so this term is x. So we have 7 here, we have 4x here. So this sum becomes 7 plus 4x over x squared. That's our first fraction. So we get 7 plus 4x over x squared divided by, we have to find what in green there the difference between those two fractions are. So let's start here. 6 over x minus 3 over x cubed. And again, the shortcut would not be a good approach to this question because the denominators here are not prime, right? So, okay. So with the LCM of x and x cubed, in this case, my LCM is going to be x to the third power because it's the largest power. So again, by the setup, the LCM goes down here of x cubed. Six over x, 3 over x cubed. Multiply the same term top and bottom for that first fraction. Possibly a different term for the second fraction here. And again, we want this to be x times another term to give us x cubed. That has to be an x squared. X cubed times another term has to be x cubed. That term needs to be 1. So we'll end up here with 6x squared and 3. So this gives us 6x squared minus 3 over x cubed. And so this is going to be the fraction, I should say, in the denominator portion here in green. That's 6x squared minus 3 divided by x cubed. So what we have here in gray is one fraction, and green is another fraction, and here we're going to divide. Seven plus 4x over x squared divided by 6x squared minus 3 over x cubed. This is now a horizontal definition of division here. So we keep the first fraction the same, 7 plus 4x over x squared, and we multiply by the second fraction, x cubed over 6x squared minus 3. You're going to multiply across. We get 7 plus 4x times x cubed over x squared times 6x squared minus 3. And now you simplify here. And the only place you can simplify is with these fractions here, x squared and x to the third. So what that means is 2 and 3 here, this fraction's gone, this power here is 1. So we have here 7 plus 4x over x to the first power over 6x squared minus 3. Now what we can do here is switch the order, and you have now x, 7 plus 4x over 6x squared minus 3. Now here nothing cancels, but you can also see this question here, or this answer, as 7x plus 28x squared over the 6x squared minus 3, because you've chosen to distribute. You can also switch the order of the numerator, and you end up here with 28x squared plus 7x over 6x squared minus 3. So here's your final answer. And this is question number 11. X minus 9 over x over x plus 4 over x. So you have a difference in the numerator and a sum in the denominator. So there's some work to do. Don't forget, at the end, we are going to divide. Okay, x minus 9 over x, the first fraction, you're going to divide by 1. And this is a good candidate for the shortcut. Meaning, you're going to cross multiply, meaning diagonal across, and then horizontal across multiply. It's weird. So here's our diagonal across and then our horizontal across. And we do this because 1 and x are prime. So we'll end up with x squared minus 9 over x. And that's the first fraction. That's the one on top. X squared minus 9 over x. This is equal. The second fraction you have x plus 4 over x. And this will be over what? Over 1. So I cross multiply here, and I horizontal multiply over here. We're going to take a shortcut. That gives us x squared plus 4 over 1 times x, which is x. So the second fraction is x squared plus 4 over x. You have again a numerator, a denominator fraction, and we're dividing here. So write your division horizontally. Use your definition of division, meaning you keep the first fraction the same and you flip over the second fraction. And again, now you multiply horizontally across. x squared minus 9 times x over x times x squared plus 4. We can cancel these x's. And you're left with x squared minus 9 over x squared plus 4. And you cannot cancel here your x squareds because the operations are not multiplication. You see addition and subtraction there, so we can't cancel these x squareds. And you can factor the numerator. It's factorable. X plus 3, x minus 3, but it doesn't cross out or it doesn't cancel with the x squared plus 4 on the bottom, so you're done. This is a simplified fraction. That was the answer for question number 13. We now have 15. A minus b over 1 over a cubed minus 1 over b cubed. So we have a difference here on top. There's no fraction. And in the denominator again, we have a difference of 2 fractions here. So the only work we need to do initially before we ultimately divide would be the work on the bottom in the denominator, the work in green. So I have 1 over a cubed minus 1 over b cubed. And in this case here, if I use the shortcut or use the LCM method, we're going to get the same answer. So I think it's good to use the shortcut, meaning cross multiply, diagonal across, and then multiply the denominators. So we'll get b cubed minus a cubed over a cubed b cubed. So this here is the second fraction. The numerator here is a minus b. So we have here a numerator. We have here a second fraction here. So this becomes, if we use our definition of division, horizontal, a minus b divided by b cubed minus a cubed over a cubed b cubed. This is in parentheses. And you have a minus b in parentheses here times now a cubed b cubed over b cubed minus a cubed. So we're going to multiply here again straight across. Here's what you end up with. A minus b, a cubed b cubed over b cubed minus a cubed. Now we can do some factoring here in the denominator. We can factor this here. This is going to be the difference of perfect cubes. So when we factor that difference of perfect cubes, this is b minus a, b squared, ab, plus and plus. So what you can see now here with a minus b, a cubed, b cubed, over b minus a times b squared plus ab plus a squared. Now the only terms here that can be canceled out is if we continue to factor this difference here. We can factor out, for b minus a, we can factor out a -1 and write this as a minus b here. So this bottom term can be factored. The top can also, but we're going to factor the bottom here so that the a minus b cancels. So we got this a minus b canceling. It's gone here. So here we're going to end up with a negative a cube b cube, or a cube b cube here, with that b squared plus ab plus a squared. And you're done. X plus 3 plus 2 over x over x plus 2 plus 5 over x. So notice here we'll have a sum in the numerator position and a sum in the denominator position, followed by our division here. So let's do some work here. X plus 3 plus 2 over x, and then this here is over 1. So our shortcut of cross multiplication, that's diagonal, then multiply the denominators. This will be helpful. X times x plus 3 plus r2 over x. You end up with x squared plus 3x plus 2 over that x. This is for the numerator in gray. The denominator of x plus 2 plus 5 over x. This is over 1. Cross cancel and multiply the denominators. So this becomes x times x plus 2 plus 5 over x. So when I multiply, I get x squared plus 2x plus 5 over x. So this becomes equal to x squared plus 3x plus 2 over x over x squared plus 2x plus 5 over x. Because this portion here is my numerator, this portion here is the denominator, and again, we have to divide. So we're going to do that kind of division here. We're going to write this question again now. This is vertical definition of division. We've got to write it horizontally. Here's horizontal. X squared plus 3x plus 2 over x divided by x squared plus 2x plus 5 over x. Again, top and our bottom. And don't forget to divide. Here you go. X squared plus 3x plus 2 over x times x squared plus 2x plus 5. So division is actually multiplying by the reciprocal fraction of the second fraction there. Okay, multiplying by the reciprocal of the fraction on the right. So now you end up with x squared plus 3x plus 2 times x over x times x squared plus 2x plus 5. What cancels is this x and this x. They're gone. So you're left with x squared plus 3x plus 2 as a numerator over x squared plus 2x plus 5 as a denominator. Now ideally at this point, what you can do here is factor the numerator because it's factorable. The denominator, though, isn't factorable. So we want to see whether or not we can cancel. And as you can see, the x plus 2 here and the x plus 1 doesn't cancel with the x squared plus 2x plus 5. So that means you have a simplified fraction, and that means you are done. This is your final answer.